Alright, in this video we're going to look at a quick review of the distance formula and then how we can apply that distance formula to what we're currently working with. So one way would be identifying what type of triangle we're looking at based on its sides. Is it equilateral, scalene, or isosceles, as well as finding the distances in the coordinate plane so that we can use those distances to determine perimeter or even area of that triangle. So real quick, the distance formula, its purpose is to find the distance between 2 points or the distance of a line segment on a coordinate plane when it's not vertical or horizontal. When we can't just count that line, we can use the distance formula. As long as we know the coordinates of the 2 points, we can use that to find the distance of that line segment or the distance between the 2 points. So here's the distance formula. Here's the 2 coordinates from that last line that we had. The way we plug it in doesn't really matter as far as which one's x2 and y2, which one's x1 and y1, as long as we're consistent with it. So we'll take our x coordinates, 14 minus 2 squared. Now we'll take the y coordinates, 9 minus 4 squared. We will be adding these together, but first we need to find the differences and then square those differences. So 14 minus 2 is 12 squared, which is 144. 9 minus 4 is 5 squared, which is 25. We'll add these together, which is 169, and then our last step is square root. And there's a few things we could do. We could simplify it in radical form if it's not a perfect square. In this case, it actually is a perfect square. The square root of 169 is 13, so that line was 13 units long. But if it's not a perfect square, dealing with the decimal is okay, especially if we're just going to be comparing the sides to determine what type of triangle it is, or if we're going to be finding the perimeter or the area, we need those exact sides. Even if it is a decimal, we would just use the decimal for whatever the square root is. And again, the application would be if we have a triangle on a coordinate plane and we don't know really anything about it, we could find those coordinates and use those coordinates with the distance formula to find the distance of each line. And once we know the distance of each line segment of the triangle, we know what type of triangle it is. For one, we could find the perimeter, and then also if we identified what the base was, so if this was our base, and then maybe we also found the height of that triangle, because remember they have to be perpendicular, we could also find the area.